Thank you for coming. My name is Ram Mohan. I'm the Chief Technology Officer for Whois. Whois is a domain name registry company, so we manage top-level domains. We're probably a company you've never heard of, but you've probably heard of the TLDs that we run. We run .org, we run .info, and we run .io for those of you who track that. So lots of country codes as well as top-level domains is what we do. One of the things that we do in running all of the top-level domains, we're the second largest in the world. We've got about 24 million domain names that we manage. And one of the important things that you find out is if you want to look at domain name data, if you want to look at who is registering DGAs or what kind of spam or what kind of phishing attacks are happening. Typically, one of the ways, the vector that it gets through is through domain names. And this is an important area, and everybody takes it for granted that you can find out who has registered these names. Where is the information, and that you can get this information. It's typically done by a protocol called Whois, and it's been around for a very long time. And I'm here to actually to chat about what's coming next and what's actually on its way to replace Whois, and to chat a little bit about how that replacement of the Whois is actually going to be very good for cybersecurity, for securing networks and securing systems. So, it's used for lots of legitimate uses. There are a lot of proper uses for domain name registration data, and you see many of them listed there. DNS abuse, breaches, maintenance of systems. This Whois information is also used if you apply for a digital certificate and you want to get that, the agency that is generally issuing the certificates typically looks at the Whois record for the domain that you're applying for the certificate for to verify that you are actually who you say you are. So there are lots of proper uses for these. Now, the thing is that to get access to all of this data, you need this data to be, the access to be fast, you want it to be automated, and you also want to be in a situation where when you're looking for that data, you're not stymied by things like being heavily rate limited, or you're not stymied by having systems that say, I don't recognize who you are, and therefore I cannot give you access to this information. Now, in our own company and in many other companies that use this, they create scoring systems. They say, here's a domain name, let me give it a reputation score. And if you look at spam detection systems, they assign reputation scores both for top-level domains as well as for domain names themselves, right? And part of what some of the spam detection systems do is also look at the ownership pattern. And they look at length of ownership of a domain name, how long has it been there, how frequently is the DNS updated, lots of little parameters that are available and accessible through the domain name registration data. And what's happening is that if you go to most registries or you go to most registrars, you go to GoDaddy, for example, and you go look up a domain name, if you're a security researcher, you'll find that after about the third or fourth query in a given hour, you'll get blocked. You'll get rate limited. And if you're a security researcher looking for information across a spectrum of names, you actually can't get access to it in any easy or reliable manner. Now, what it also does is that the availability is being constrained not just by to those who have a legitimate need. It's also being constrained to those who have, so when I say legitimate need, one kind of legitimate need is somebody in law enforcement, somebody in a security research part of a company that says, I want to do this, or a company that primarily does security analysis. But it's also something that law firms use. Somebody goes and registers a domain name and it infringes upon your brand. and you want to go put a notice out, pretty much the only way you can find out who owns the domain name, who to send the notice to, is via the Whois interface, right? And if that interface gets blocked, or if that interface is not easily accessible, there is a real life problem for it. There are also a few unresolved policy issues. One of the biggest ones is, who should see this data? Who is actually legitimate? And who decides who is legitimate? Today, the way it is done, the legitimacy is completely determined arbitrarily by whoever has either access to the data or has the data, right? So if you look at a domain name registrar, somebody like a GoDaddy, or if you look at someone like a VeriSign that runs the COM database, et cetera, you'll find that they will decide whether you're a legitimate user or not. Now, if you have a subpoena from Europol and you come into a company and you say, I want to have access to the data, you may or you may not get access to the data. And that's a company policy. And we're not here to solve that problem, but I'm just laying out what the landscape looks like and what the problem area looks like. The fundamental issue, though, is that what's happening is, with the way Whois has been done and the way Whois works, it's a one-size-fits-all solution that has been around for 30 plus years. And what that has done is when companies that have the data, if companies want to give differentiated access, tiered access that say, okay, you're law enforcement, okay, you're a security researcher, all right, you are from a law firm, you will get access to a certain kind or a certain amount of data, and you're just a regular Joe on the internet who wants to look up, you get another kind of access. There is no such mechanism. It just doesn't exist today. That's one thing. The second part of it is that Whois, when it was originally created 30 plus years ago, is just text-based. And as you probably know, with the domain names and with email addresses that are now allowing Unicode characters and that are now allowing internationalized characters, Whois doesn't even know how to display them because it's ASCII only. That's all it can do, right? So today there are 1,300, give or take, top-level domains on the internet. Of those 1,300 top-level domains, there are about 150 that are in languages other than in the Latin script. Right? In the Latin script itself, you have domains that are in Spanish and in French and things like that. But I'm talking about domains that are in Arabic that are written right to left, and there are domains that are in Chinese and Japanese and so on and so forth. Right? In the Whois, you can't make out what they are. All that happens is that it's converted into an ASCII format called Punicode, and that's what's displayed. But if you ever try to go and look up a Punicode name, it's just gobbledygook. It says XN -- and then a hash, and that's good for computers, but it's not really good for human consumption. So the technology, the new technology that is coming up, and the new protocol that is coming up is called the Registry Data Access Protocol, ArtApp in short. And ArtApp is an alternative to the Whois, and what it allows any client to do is to query resource registration data on basic internet resources, and there are really three categories of them: domain names, IP addresses, and ASNs, right? So this is the protocol itself is done really for the modern internet. So the responses are delivered in JSON. It's RESTful, and the other advantage is that you end up, as a provider, all you end up doing is focusing on delivering data over HTTP. You're not booting up your own system. You're not running a separate protocol and running separate servers on a separate port. Today, Whois, for example, runs on port 43. And with ArtApp, you don't need to go open up that port and run it in that area. And because it is running on the web, it supports all of the things that you expect on the web. So I was talking earlier about Unicode characters and UTF-8 characters or UTF-16, whatever it is that you want. All of that, both the domain names themselves, but also the registration data associated with the domain names, all of that are now available and can be displayed in local languages. So I'll tell you a story. Japan runs, their name is .jp. That's what they run. And it's run by a nonprofit in Japan called JPRS. And about 15% of all of the .nippon names that are written in katakana, in the Japanese script, about 15% of all those domain names that are registered, the information about who owns these names, the information about who is the admin contact, who is the technical contact, everything is only in Japanese. Okay, there's nothing available in ASCII, nothing available in English, so to speak, right? If you try to get any of that data via the Whois, in most cases, unless you have a Whois system that has actually been adapted and customized by and run by JPRS, your Whois system will crash. It just can't, not only can it not handle it, it actually gets an overload because it's not just the domain name that is in Japanese, but all the data that is associated with it, right? So ArtApp actually solves that problem very elegantly. It is, natively supports Unicode, natively supports internationalized domain names. Another piece of kind of the next generation of technology that's coming up is, we're used to email addresses that are, just written in the normal way, a@b.c. But if you look at new top-level domains, there is a top-level domain called .shabaka. Shabaka means shop in Arabic, and it's an Arabic name, so it's written right to left. Email addresses in that particular zone are completely in Arabic. So everything is written right to left, right? The app is the only thing, and the dots are the only thing that, from a protocol point of view, are parsed left to right. Everything else is right to left. If you try to display that in the Whois, you will get pretty strange results. Mostly because Whois is expecting everything to be left to right, okay? And Whois doesn't know how to handle, Unicode characters in any way. So just to come back to what makes ArtApp different, the semantics for both requests as well as for answers, including standardized error messages, they're all structured, XML-based. The contact details that you access, all of that is via HTTPS. You can add the elements on the responses. You can add output elements, and you can configure it and you can expand it on demand. So it's a pretty extensible protocol from that point of view. And the bootstrapping mechanism is actually a pretty cool idea. What it allows is, and I had said this, I think out here, you need a bootstrapping service. What that means is that you're not limited to having your queries go to just one place to get your answers back. If the queries are not being answered appropriately or fast enough, or you have poor performance from one service, you can simply go to another service, or you can bootstrap your own, right? So that's pretty cool, I think. Of course, it's, as I had mentioned earlier, it's RESTful. Output data translation is pretty uncomplicated. And as I had mentioned earlier, you have the ability to grant differentiated access and tiered access for contact data. This table just expresses in a fairly compact way the differences between ArtApp and Whois. I won't go through each of the rows here. The thing that would be, I think, interesting is that responses are automatically sent to other registries. That third row that's in there, that I think actually has pretty interesting consequences. What that means is that you can actually daisy chain a bunch of ArtApp servers, and you can pull together information about a variety of zones at different levels of that name itself without having to switch server to server to server, right? That's on the client side. On the server side, what it could also allow you to do is you could run an ArtApp server and not have any of the data. All you simply do is you bootstrap a device and you point to the next server that actually has the data, but you still simply handle the tokens for authentication. And with the token, you can go grab the data, bring it back, and display it. Now, it sounds like it's a fairly complicated thing. The really interesting piece of it is that if you are worried about regulations that have to do with privacy, if you're worried about how do you comply with GDPR or other things like that, here's a pretty elegant way to do it. You can show the data, but you're not processing it. You're not storing it. All you're doing is displaying data that has been brought from another source, right? So if you look at it from a pure compliance and from legal and regulatory point of view, as a protocol, this actually provides a very elegant and a good way to present that kind of data. There's quite a bit of text here that you can read, but some of this I've already spoken about. The first two bullets I've already spoken about. Let me talk to the third one. If you look at Whois and you want to scale up Whois, and we run Whois systems in our systems, and let me tell you, when we got started in 2001, we were running just .info. And .info was an unknown top-level domain. Nobody knew what .info was, and at that point, honestly, nobody cared about it. So we ran a fairly small instance of the Whois systems, and we were running it. Well, as we grew and we added .org to our stable of TLDs that we were running, as we added other top-level domains, what became clear was that the only way to really scale on the Whois was to do it the good old-fashioned add more iron way, right? And it's more of vertical scaling rather than horizontal scaling. And I'm actually pretty excited that with ArtApp, we'll be able to get to just cloud-based, just horizontal scaling and be able to expand the amount of, the number of Whois instances without actually having to incur the extra hardware costs that come with it. A few other things. I'd already mentioned bootstrapping, but the second bullet I think is interesting. I'd spoken to this, I'd alluded to this just briefly, but responses from ArtApp can actually contain links to other resources. So today, for example, in the Whois, if you ask, who owns this domain name, typically you will get back a basic set of information. But this allows the responses to add other links. So you could say, I have only limited information, but if you want more information, here is a URL you can go to. Or you could say, if you believe this domain name is, or you could say, if there is an abuse that has to be reported, here is a URL for that abuse to be reported. There's all of those kinds of mechanisms that do not exist in today's systems that ArtApp actually allows you to do. And it also allows you to provide the responses in a very bespoke manner. So depending on who you are, and depending on what level of authentication or what level of validation you have, the amount of information I give back to you is either smaller or larger, and that is completely configurable, on the fly, done. You configure it once, and then it just does it all the way. You really cannot do that on today's Whois. If you really want to provide differentiated access, and if you want to provide granularity of what data you're providing and what data you're holding back, you got to write custom code for it. There is no standard protocol-based way to do it. ArtApp actually lets you do that. And I mentioned access control. ArtApp is actually really smart about how access control works. And you can make dynamic decisions on access control. So you can say, for example, access is on a per transaction basis, per query basis, per session basis, and it integrates with OAuth, it integrates with OpenID, and so it has good integration with two really good authentication standards that are out there. And if you look at access control, the horizontal scalability, and the authentication mechanisms, OAuth, OpenID, et cetera, what it actually means is that if you are somebody who is sitting on a database of IP addresses or a database of AS numbers or a database of domain names, you don't need a separate device to do rate limiting. You don't need separate systems to do rate limiting. It's built in to the way ArtApp is actually designed. And I'll show you a little bit about in a couple of slides on how the design actually works. But I want to switch a little bit to the security aspects of ArtApp and what ArtApp, how it integrates security. So by itself, ArtApp doesn't have any native security services. Because it's sitting and is delivering information over HTTP, it really depends quite a bit on protocol-based, layer-based security systems and security aspects that are in there. So, like I said before, it works over HTTPS, so you know that there is some level of encryption, some level of data integrity once you actually get to the site. Now, in addition, the registration data, the access control of that data it requires you have to pick either OpenID or OAuth, one or the other. So you are required by default, by definition, to actually have pretty strong authentication and validation in order to even access the data. And I'd mentioned about differentiated access, and I'll speak a little bit more about that. There are other pieces in here. ArtApp allows the creation of a status member in the response, so it can come back and provide the kind of data that was given to you based on your access level. Now, we found that if you look at, say, law enforcement, or you look at banks or law firms, they find this useful because it's effectively an automated audit function that's just built in. You don't need to write extra code for it. You don't even have to go through logs for it. It's just built right in there. There is federated authentication ID, authentication mechanisms that are also present, and I'll speak to that in just a few minutes. And the data integrity piece, I think what you'll find with ArtApp is that by itself, ArtApp does not guarantee integrity for data. But because it supports running over TLS, you can actually implement that. It's an optional thing, but you can implement that to make sure that access to the data has good integrity and good security with regard to how that is done. I spoke a little bit earlier about the design function itself. It's built on a Spring Boot framework, and it uses the Log4j2 framework for logging itself. So those are the two primary frameworks that ArtApp uses. The REST service is on HTTPS only, and clients can validate certificates used by the server. There are two RESTful methods that are supported. The GET and the HEAD methods are the two RESTful methods that are supported. And it's available over both v4 and v6 IP transport. And to get to the registration data, there are multiple layers to access it. And you can have public access, you can have personal data access, you can have different access profiles. And depending upon the access profiles, you can decide how much or how little access can be provided. I don't know how much you can see this diagram, but this actually shows you a little bit on what actually happens. You know, you have a request that comes in from the actor, you know, goes into the rate limiter. It's HTTP request, goes in straight to the rate limiter. The rate limiter decides, you know, are you going to be allowed to get that information? Is it going to be blocked, or is it going to go forward? Once that decision becomes a positive one and you can go forward, it goes to the data controller. The data controller, all of this up to here is it's really HTTPS. It's not HTTP. I mean, it's HTTP, but it's running secure. Goes to the ArtApp system. The service then does a couple of things. It does a method call to the database, the actual data where it's stored. And in addition, it sends off a request into the reporting updater, as well as to a parser, right? So it does three things. The ArtApp service does three things. The database provides a response goes back all the way, but in addition, it also goes to the parser and to the reporter. And there is a handler for error messages or for other audit messages that can be tracked after completion of the request. So it's a fairly elegant, fairly straightforward system to go and implement. And bootstrapping an ArtApp server is a pretty trivial thing. There's a bunch of source code that's already out there. I spoke on the previous slide about rate limiters. So there are several configurations that are provided in ArtApp for rate limiting. That's just built in, and it uses the token bucket algorithm. And that, you know, for those of you who know this, it's a well-known method to throttle and limit network traffic. And what the implementation does is you can look at IP addresses of the requester, and you can limit that. In today's Whois systems, you need a separate device to go do that. If you want to look at IP-based rate limiting or throttling, you need a separate device. So this is going to really make it much more efficient. I spoke earlier about security features. I want to go into a little bit more depth of what these are. So access control, you know what that is, and it includes features to identify, authenticate, as well as authorize clients. And what that means is that server operators can control access to information based not just on the identity of the client that is making the request, but also what level of authorization that client has. So that's a level of granularity that just has never existed. It's the first protocol that actually allows that level of granularity. Authentication, the framework accommodates two parts of it, both anonymous access as well as verified identities. And the responses have to be either conforming to basic authentication or a digest authentication. And as I'd mentioned earlier, it includes TLS support for digital certificate-based authentication as well. So there's pretty robust authentication framework that's been built in. This is one of the most exciting pieces of ArtApp and an ArtApp implementation is federated authentication. In a traditional client-server model, it requires that every client has to maintain a distinct credential for every server that it accesses. So if you look at Whois, for example, if you wanted to query Whois in com, for a .com domain name, and if you wanted to query the Whois for a .org domain name, you need to have two separate set of credentials to get appropriate access. In a federated model, what it means is that the clients only need one credential, and with that single credential, they can access multiple ArtApp servers, right? And of course, that means that from the client side, it reduces the complexity of credential management. What it also means is that from the server side, from the serving side, the client token that comes through is embedded in that token is information about the level of access, not just your identity, but as I had mentioned, where is this? There you go. The token allows not just identity, but also authentication as well as authorization. Right? So that means that in a federated system, your identity, your authorization, as well as your the validated parts is automatically made available to all ArtApp servers that are accepting your queries. And that's a dramatic simplification overall. When we talk to folks in law enforcement, when we talk to Europol or we talk to the FBI, et cetera, this is something that is really important for them, because in today's system, or we talk to folks in security researchers, it's a really useful system that's being brought forward, because in today's model, they need separate credentials, separate IDs, and separate authorizations to go from one database to the next. And if you're a security researcher, you know that if you're looking at a particular problem space, you start with the domain name or you start with an IP address, but eventually you have to dig further into, if you start with the domain name, you're going to look up the Whois, but then you often also look at, you find out what are the host names associated with it, what are what is a Whois, the ownership information for the IP addresses. Then if you want to dig a little further, you look at what are the AS numbers, who owns that AS, which ISP do you go to. If you want to follow that chain, that's actually a lot of work in today's systems. ArtApp, with a federated authentication model, promises to simplify and make it far more efficient if you're a security researcher, if you're or if you're somebody in law enforcement. As I'd mentioned earlier, there is support for both OAuth and for OpenID, but there's also the way it allows authentication is both over SAML 2.0 as well as HTTP over TLS. So with SAML, for those of you who understand that, what it allows you to do is to take a token, and that token allows you to exchange information between identity and service providers. So identity providers can take a token from an actual end user and transmit that token to various service providers without compromising any PII of the user requesting the information, right? So that's a pretty good model, and that's been implemented in ArtApp. And of course, as I'd mentioned earlier, it implements TLS as well. On the authorization front, access control decisions can be made once the identity has been established and authenticated. And here are 3 examples. Clients are allowed access only to data for which they have a relationship to that data. So an example here is you're a law firm, and if you want to get access to information, you can set a rule that says you will only be given full access to information about domain names that you sponsor or that you are the owner for, or for domain names for your clients only, right? Another example is that unauthenticated or anonymous access may not give you any contact data, but it may give you other data such as when was a domain name created? When is an IP address going to expire? What are the host objects associated with the domain name? The AS number, which provider is it associated with? Which is metadata, if you will, or generic data that is not specifically providing PII with it. Or you can say that you can provide full access to a special group of authenticated clients. So it could be that there's a regulator, and the regulator is provided full access because they are required to be given that kind of full access. But that full access is done using ArtApp, which means that the access is automatically logged, is automatically tracked. So organizations that want to put out information about how many government requests came into them, how many requests for data was made by governments, and some companies are doing that. This allows for that kind of logging and that kind of information to be shared quite easily. There are a few security considerations that you have to keep in mind when you implement ArtApp. It's just running on HTTP, so by definition, it's susceptible to code injection attacks. And as I'd mentioned earlier, you can use digital certificates to federate the authentication. But we all know that digital certificates have become far less secure than they used to be because there is the advent of folks who just issue their own certs. There are rogue certificate authorities that are out there. And so that is a security consideration to be to worry about. And TLS itself only does client authentication, but because there is TLS, if you have a rogue certificate that is issued, you can actually fake this into looking like it's a secure, authenticated, proper request and a proper response, when the cert itself may be a rogue cert. So if you're somebody who is going to be implementing ArtApp, that's one of the things you want to do, is to be quite conservative in what certs you actually accept in the authentication model. And of course, TLS as a protocol has a null cipher suite, and that suite does not encrypt data. And so if you depend upon just TLS, TLS does not provide data confidentiality. It just ensures that that data has some level of encryption. But if you're looking for confidentiality, you have to implement both legal policy-based measures, not just technology-based measures. And finally, can you run your own? Can you bootstrap your own? Yes, of course. And I'd said this is one of the cool things. You can set up an ArtApp server, and you don't need the database underneath it, because you can have the ArtApp server simply point to other systems that have the full scale and scope of data. So you can set up your own server, and that will allow clients to find authoritative servers to query. Now, query bootstrapping can be expensive. So if you set up a bootstrap server, that can actually you can preload all the bootstrap information. And that can be helpful in high latency situations, or in low bandwidth, or in intermittent network connectivity type of situations. A bootstrap server is actually a very useful mechanism. And once you set it up, it's actually very simple. The ArtApp client just sends an ArtApp query. It comes over to your server, and you got a bootstrap server. But your bootstrap server isn't actually sitting on any data. So all it does is it points to whichever is authoritative server, gets a JSON response, and it just passes it straight through. It's just a pass-through layer. So very easy, very straightforward method to do it. There's some source code. There's a link up there for where you can find some source code if you want to bootstrap your own. So my thoughts on the impact on cybersecurity itself. I think federated authentication is actually implemented right, could actually transform getting access to this data, because with federated authentication comes the ability to just take tokens and use tokens to access data across multiple networks. And that should bring a great deal of efficiency. But that also means that if you're researching a phishing attack and you want to look at who is behind the phish, finding data right now is a real job. It's quite a lot of work to be done. You can now automate that. With ArtApp, you can simply automate that, and with federated authentication, you can simply go across multiple networks and bring that data back. Again, access control is a very impactful thing on cybersecurity and research and domain name takedowns and threat mitigation. Because if you are able to prove your credentials once from a proper authority, if you're able to prove your credentials once into any ArtApp server, those credentials travel all over across to other ArtApp servers as well. So that again means that if you're somebody who is in the business of taking down bad actors, you just have that a lowered amount of barrier to getting that piece of data. I'd spoken about configurable rate limits. The rate limits are configurable, but those are also based on authentication and access. So there's a great deal of fine-grained detail that you can get into. Now, structured request and answer semantics that are built into this entire protocol results in better readability, but also more importantly, it becomes far more machine readable. And this has relevance when you look at internationalized domain names in particular. Let me give you an example. If you look at, say, the word PayPal, right? There's paypal.com, but you can register paypal.com completely in Cyrillic. Okay, you can go to the VeriSign registry and you can ask for PayPal. Every letter, when it comes up on your computer, looks just like it is in English, but none of them are actually ASCII. They're all Unicode characters. They all look like they are actually PayPal, but they're all in Cyrillic. To a computer, it's a completely different domain name, and that is a great place to go do a phish. And you can do that across the board with any of the big brands, any of the big financial institutions or other places like that. Today, if you wanted to go and dig into who registered that name, and you want to dig further into not only who registered the name, but what are the hosts for it, what are the name servers associated with it, when were the last updates done to it, what AS is it sitting on, what are the IP ranges that it's on, which geography it is in, etc. All of that stuff. Each one of them is a separate query, often done at a separate source to a different server, right? Now with ArtApp, you could actually automate all of that, and you could put that request in with the federated authentication, with access control, and with the configurable rate limits. You could have a shaped query that goes in that pulls back in one fell swoop the information on the domain name owner, information on the host names, on the IP addresses, the ASNs, all of that can be pulled back together in a very easy way, and have it all be put into your database in a normalized manner. And as I had mentioned earlier, you can add additional output elements into the response because clients can decide to use it or not use it, but you can stick URLs, and there are some folks who are thinking about sticking advertisements in these. Text-based things. I don't know if that's a great idea or not, but folks are looking on how to monetize this. And because there is a single standard, just the ArtApp standard, the ArtApp protocol, it means that if you're building tools downstream, it's fairly easy. You don't have to worry about which instance or which implementation of Whois is being run. It's just ArtApp. And again, it's web-based, it's HTTP-based, not really web-based, HTTP-based, it's RESTful. Output is in JSON. Access is via APIs, which means that you can actually access this on any platform that you want. You don't have to roll a special thing. It's just available and accessible anywhere at all. So that's really what I think is coming. I think is going to change the phase of how you do research on domain names, research on IP addresses, research on AS numbers, and it ought to have a really strong positive effect on how long it takes to research who the bad actors are and how quickly you can take action against these folks. So that's all I had. Any questions? Yeah.
When do you predict the federated authentication deployed among the major TLDs?
Some TLDs have already deployed ArtApp in test beds. So .com has done it, we've done it. So the big registries have already got test beds running. I expect that by 2020, we should see all the global top-level domains, the GTLDs, ComNet, Org, Info, Biz, etc., all of those to have implemented ArtApp across the board. And I expect the big countries, the United Kingdom, Germany, Australia, et cetera, the big countries will also have implemented ArtApp. They're kind of more advanced, if you will. But there are 240 countries, and some of them, it'll probably be 2050 when they start thinking about it. But for the most part, I think, there are about 340 million domain names in existence today. I would expect that in the next couple of years, at least half of them will be running on ArtApp. And in a couple of years more from there, I expect, big, look, a lot of it also depends upon whether China and Germany and the UK and Australia, for example, show leadership and move forward, because once they take the next step, everybody else kind of follows along.
Will the implementation of this new protocol have any effect on the type of information that can be displayed as far as GDPR?
Absolutely. So that's one of the cool things with ArtApp. If you're the person who holds all the data, you're a data owner, if you will. Under GDPR, you have certain responsibilities on how you display the data, who you display the data to, where you display the data, right? And today, if you have this data sitting in your systems and say you're an American company and you have to display the data and you have to restrict data about Europeans being shown in Europe, but you can show that full data in the United States, you got to write custom code for it. ArtApp, you don't know how to do that. With ArtApp, you can simply set up a rule inside of ArtApp that says, if the client is authenticated and comes from Europe, these are the pieces of data that can be shown. But if the client comes from America, you show other pieces of data or all of the data. Anything else? All right. I hope you found this useful. Thank you.